Okay, so all of you can see the screen. Okay, so this RLE load, practically you can say this RLE load is nothing but a DC motor. So this type of converter, single phase full wave converter, is generally used when or used as inverter during regenerative braking. মানে braking মানে কোন যেতବେଳେ brake apply করিব তো there is some wastage of energy, so that energy will not waste but it will supply to the or it will deliver to the supply to the source. To regenerative, that means without any wastage we're using that energy that is you can say that is formed in during braking. Okay, so this DC, I mean the practical significance of this RLE load is nothing but a DC motor, you can say. Okay, now let's solve a problem on this RLE load. So all of you please write a question on RLE load, single phase full wave rectifier with RLE load. Okay. A single phase full wave controlled bridge rectifier, single phase fully controlled bridge converter is feeding a RLE load. A single phase fully controlled bridge converter is feeding, FEEDING, feeding a RLE load from 230 volt 50 hertz single phase supply. Okay, so it's written as single phase fully controlled bridge converter feeding a RLE load from a 230 volt 50 hertz single phase supply. The load current is constant at 15 ampere. So this is my average value, the load current. So the load current is constant at 15 ampere. So a load current value is that is my average value of the load current is given. Okay. Then the R value is given as 0.5 ohm. R is 0.5 ohm. And L is given as 0.3 Henry. Find first bit the firing angle alpha if E is equal to 100 volt. The firing angle alpha if E is equal to 100 volt. So RLE load re R and L is given and E is 100 volt. At that case, I have to find alpha. Then the second bit. Second bit is to find alpha if E is equal to minus 100 volt. So minus 100 mane, if I had connected E like this in the first case, in the second case, I have reversed the polarity. Okay. तो you can say first case रे से converter वाले act करूची and second case रे rectifier वाले act करूची. Okay? I'm audible?
Second case में भी inverter.
हाँ, inverter. So obviously more answer to alpha greater than 90 ଆସିବ. Then the third point is find the input power factor in both the cases. That means when E is equal to 100 volt, when E is equal to minus 100 volt. Then the fourth one you all will do by yourself. Draw the waveforms of V0 at firing angle of this one, alpha 1 and alpha 2. Alpha 1 and alpha 2. That means Vs and E will be there, and then V0 at alpha 1 and alpha 2. So as discussed last class, RLE load when alpha less than 90, because first case re more alpha less than 90 asibo, but a case re more alpha greater than 90 asibo. So that waveform you have to draw, but with the difference that you have to mention the alpha only. Okay, alpha mention. Okay. So now understood the question. So it is a single phase full wave control rectifier, bridge converter koichi. So it's a rectifier with RLE load, and this one is the supply. So 230 volt is which value? Supply RMS, isn't it? So 230 volt, 50 hertz single phase supply. Load current is constant. Maneki say highly, like suppose I told Amara, because of IL, I should have something like this, increasing, decreasing. But Jetu, the IL may be highly inductive, so it appeared to be a constant value. So 15 ampere. Then our LDH error value 100 and minus 100. So we have to find corresponding alpha. So how to find for this? So first, all of you draw the converter without looking at any book. Bridge converter means 2 arm will be there, and fully control means 4th thyristor. So without looking at the book, just to test yourself whether you remember the converter or not, draw the converter diagram first. So this I0 is how much? 15 ampere. So first case more E positive nature. So 100 volt. And then the VS 230. Okay. So since it is a constant current, if I suppose if I have to apply the KVL, so KVL apply kale kemti hobo? Suppose positive half cycle re, assuming this to be T1, this is T3, this is 4 and 2. 1, 3, 2, 4. I'm naming the thyristor T1, T3, T2, and T4. The positive cycle ray, which thyristor will operate? This one, 1, and then 2. That means plus.
First 58.74.
Good. So first positive cycle, then T1, then RLE, then T2, isn't it? So KVL apply kale kemti habo?
2Vm by pi cos alpha equal to E plus I naught R.
Okay. So why I have not considered the voltage drop across inductor?
Constant current na change nahi to drop hoga.
Good. So this output voltage, good. So this output voltage V0, so V0 is across this RLE load. Okay. And V0 is what? It is the average value, output voltage or average value. Hala. And this we know. What is the formula? V0 is equal to 2Vm by, look at the copy, Kali ko haitla, 2Vm by pi, 1 plus sin alpha.
Pi cos alpha.
Cos alpha.
Or
2Vm by pi cos alpha. This is the average value of the output voltage. And this V0 will be equal to the voltage drop across this R. देखो एटा हला प्लस माइनस हमरो नोटेशन अछि हला तो इवन ई बी मोरो आई मीन इन एडिटिव टाइप अछि हला so this V0 is nothing but voltage drop across this R plus voltage drop across this inductor plus this E. Okay, so E we know it is 100 volt. R will be how much? Voltage drop across your R kete hobo? Voltage drop across R will be how much?
7.5.
अरे मैंने केमती फाइंड आउट करिबी?
I naught into R.
This V0 is nothing but the voltage drop across R plus voltage drop across L plus E. This one everyone is clear? This V0. Clear everyone? एटा हला गोटे पार्ट हला V0 जो हमें एक्सप्रेशन बाहर करलु 2Vm by pi cos alpha, and this V0 is also equal to this. माने जदि या across रे if I use a multimeter or if I use a voltmeter, what it will give? It will give the voltage drop across this R plus the voltage drop across this L plus E, isn't it? Eta clear ho everyone?
Yes, sir.
Sekhar Lama, Navista, Priyanshu. This is clear?
Yes, ma'am.
Good. So this V0 is nothing but the voltage drop across each element plus your E. Okay? Now how to find out this voltage drop across R? That is equal to I into R na? VR is equal to I into R. So 80 more I kon achi, this one. I0 into R, that is 15 into 0.5. ठीक है? So voltage drop will be how much? I0 into R. So I0 is how much? 15. 15 into 0.5. कितना असला?
7.5.
7.5. Plus voltage drop across L. तार फॉर्मूला कितने? Voltage drop across L.
LDA by dt.
LDI by dt. But here my I is constant. तो I constant हेले कौन होगा? di by dt?
0.
0. Derivative of a constant is 0. So di by dt is 0. So V equal to 0. So either you can so Jyotirmay.
Yes, ma'am.
Okay. So instead of like theoretical we also saw Jadi I is constant, so VL is equal to 0. So either you can write like this or directly you can write since I0 is constant, so voltage drop across the inductor is 0. Hela, either sentence likhi paribo or else you can write like this also. Okay, so this one is equal to L di by dt. So this is 0 because it is constant, plus E. What is the value of E here? First case 100 E. Okay, so this one 7.5 plus 100, and this V0 we know the expression, that is equal to 2 Vm by pi into cos alpha. Vm value is given. Amra, we have to find here alpha here. Okay, but Vm value is given or not? Vm kona, the maximum value of the supply voltage.
Single phase तो 230.
230 into root 2
रूट 2 ना 230 वोल्ट है कौन आरएमएस वैल्यू.
voltage.
ठीक है, सिंगल फेज एसी सप्लाई हेले बी दिस इज माय 230 वोल्ट, दिस इज द आरएमएस वैल्यू. ओके, सो वीएस जोटा दैट इज माय आरएमएस वैल्यू. तो तारो मैक्सिमम वैल्यू केते हबो? এটা হলো আমার আরএমএস ভ্যালু. সো দ্য ভিএম ম্যাক্সিমাম ভ্যালু উইল বি রুট 2 ইনটু ভিএস. So this you remember. So Vm is equal to root 2 into Vs. So you can say Vm value is also known. So here we'll write into root 2 into 230. Now you can find alpha. So all of you find alpha and tell. Two root 2 third 31 230 na. So this Vm is equal to root 2 into 230. Find out alpha. All of you calculate. તમે confuse कीजिए pi, radian, degree.
$59.26.
59.26. Okay. Ankit Samant Singar. Alpha value कितने असली?
Yes, sir.
Alpha value. Are you calculating? Are you say yes or no?
No, ma'am.
Okay, but calculate hela, because you may get confused.
Yes, ma'am.
आओ की बाहर करना क्या आंसर? अरिश्मिता, what is the answer?
Ma'am, 58.72.
58.7374. 59.2 যদি আসছে, you have put the
Yes,
same.
ma'am, 58.7.
हाँ. सेवन थ्री सेवन टू କାହାର ଏମିତି ଆସିଛି, ଆଉ କାହାର ଆସିଥିଲା 59.2 ଆସିଥିଲା ନା. तो मे बी द अप्रोक्सीमेशन को तो नहीं तो हाँ अच्छा √2 पाई सब्स्टिट्यूट कौन कर माने बाय पाई लिख लो ना 22/7 ना कौन कर लो
Ma'am, file.
So this is the answer. Okay, so you can see it is less than 90. तो एटा भी वन ऑफ माने वन वे टू क्रॉस चेक लेस देन 90 माने हाँ ठीक अछि बट तापरे कोन 60 61 से दैट आई कैन नॉट से बट हाँ लेस देन 90 इट्स ओके ओके नाउ कमिंग टू द सेकंड केस is empty but E is reversed. Okay, so in the second case also that V0 will be how much? The voltage drop across R plus voltage drop across your inductor plus एबे मोर ईटा कौन हेगला माइनस ई उल्टा हेगला ना माइनस ई सो this is same as like 15 into 0.5 that is 7.5 plus 0 minus 100 then again v0 is equal to 2 vm by pi cos alpha vm is nothing but √2 vs it is 2 into √2 into 230 now ebe find out kar alpha
116.517.
हाँ 5.1 or 5.2 okay.
It's 5.7 to round with.
ठीक अच्छी तो 116.52 degree so here you can say it is greater than 90 कार answer asla just respond
Yes, ma'am, Asila.
okay good now let's find out the input power factor so all of you are clear with this first 2 point all of you are clear
Yes, ma'am.
then input power factor at E is equal to 100 volt so this is a rectifier na it's a converter which converts AC to DC ठीक है तो to find out the power factor the expression that we have to use is like input side power is equal to output power neglecting the losses of your thyristors ठीक है input power is equal to output power so input power is on the AC side input power माने कौन सी को power AC power clear input side मोर AC रोची ना तो input side power टा कौन AC power yes
ma'am.
हाँ output side I have a DC so here the power will be DC why I am saying AC power DC power because there is a difference in formula to calculate the power in AC supply or in AC side and to calculate the power in DC side so in AC side the power will be like VI cos phi the RMS value VI cos phi ठीक है but since this is input power so we have to consider the input side voltage input side current okay so input power is equal to VS IS cos phi that is equal to the output side power now the output side power so here we will have the power because of I mean there will be a power loss because of R माने कौन सबले power loss रोची I square R ठीक है and L since it is a constant so we can say the power will not consider the power of L there is no drop here माने no loss okay and because of 100 volt we'll have V0 I0 VI the DC power okay so On the DC side, we'll have I0 square R plus we'll have, because of your E, so we'll have E into I0. The power, mane EMF, source of EMF will also deliver a power, na? Okay, so E into I0. So you can say when E is equal to 100 volt, the input power that is supplied to the load is the sum of this power loss I square R plus E I0. Clear? Okay? Okay with this expression? So Vs will be your 230 because I'm a VM use करने 80 Vs use करचे into Is will be same as the load current, that is 15 into cos phi. तो A cos phi टा कौन? What is this cos phi? Power factor. Okay. So into cos phi, that is equal to I0 square, that is 15 square, into R is your 0.5 plus E0 100 into 15. So from here, you have to find out PF, cos phi. So the answer was 0.467. Lagging because of the presence of inductor. Okay, 0.467. Clear with this? Okay. Now, if we go for the second case, that is E is equal to minus 100 volt. So here, in E, we'll only substitute here minus 100, the value. Jadi expression wise jiba, okay, theoretically I'll explain you. Just let me write it. So Vs Is cos phi is equal to I0 square minus E0, E I0. Okay. So what does it mean? যদি আমি এটি minus E कर दबा, minus E माने polarity reverse. So we say that it is acting like an inverter. That means it is supplying the power from the load to the source. Na? Power flow hochi from load to the source. This is supplying power. That means this power should be equal to the power, that is AC power Vs Is cos phi plus the power loss in your R. बुझिला second case का था, when it is E is equal to minus 100, that means it is supplying power to this AC side plus the power loss in R. So in this expression also, if I write like this, E I0 is the power delivered by E, source of EMF E. So E I0 is equal to I have written wrong, I think.
E I not minus I not.
हाँ, E and not minus I not. Current direction उल्टा है. Okay, else we can write like this. This E I0 is the power delivered by E, that is equal to Vs Is cos phi plus the I0 square R. Okay. So from here you will find out cos phi, that is equal to 0.402 lagging. Okay. So once again, all of you go through this problem. निजे, I mean calculator use करके solve करो and also draw the waveform. Okay. Now ଆଉ ଗୋଟେ ହଁ and I have asked one question to you all 2 days back. Single phase full wave rectifier with with RL load, there is a freewheeling diode. तार waveform के ही draw करिश? Anyone? Drawn ना forgot ना कौन? With freewheeling diode. तो freewheeling diode हेले कौन हम्बा? What is the importance of this freewheeling diode?
Load output
Negative part रही बनी.
just as given.
That means negative part रही बनी. तो like if current तो किसी change ऐसे बनी जहाँ तेला सेमती ही only there will be a change in your V0. So V0 because of RL load we were having like this. There was a negative part. But when there will be a freewheeling diode, that means we are allowing a path for the discharge current to flow. Isn't it? Mane RL load jogu, we are allowing a path for this the discharge current to flow. So there will be voltage drop across RL kon hi jivo 0. So there will be no negative part due to the presence of freewheeling diode. Understood? So what is the advantage of freewheeling diode that we had already discussed in your half wave control rectifier? What is the advantage of freewheeling diode?
Output performance is better.
Because the average output voltage increases and hence the power factor also increases. 8 point तो कही पर ना average voltage increases, negative part नहीं तो V0 average voltage increase करूची. Okay, so these are common questions you should know. मैंने वो पढ़िया भी दरकार नहीं. Okay, now the last class. Semi-converter. Did you go through the theory of semi-converter? So what is the semi-converter? What is the difference between full controlled and this semi-converter? Is it full controlled?
No, ma'am. Ma'am, it consists of two diodes. No, ma'am.
So what is the difference?
Ma'am, it contains two diodes.
Good. That means in fully controlled we have four thyristors or 4 control switches, whereas in semi-converter we have only 2 control switches and 2 diodes, 2 SCRs and 2 diodes. Okay. So this is one difference between your fully controlled and your semi-converter. Okay. Now, yesterday it was discussed, but I'll explain again. So we have like 2 type of configuration, symmetrical and asymmetrical configuration of a semi-converter. So this is single phase or 3 phase? Which type of semi-converter? It is a single phase because I made a single phase AC supply. Okay. So in symmetrical configuration, in one leg, you can say we have a thyristor and a diode, and this is my second leg. We have T2 and D1, a thyristor and a diode. Or you can say it is symmetrical about this axis. It is a mirror image. But asymmetrical means in one leg or in one arm, we have both the SCRs, whereas here we have 2 diodes. Okay, gote leg re dita SCR, outer leg re dita diode. And you can say jadhi it is not symmetric at this axis, mirror image no hai. Okay. There is another point to differentiate the symmetrical configuration and asymmetrical configuration is that the thyristor and diode, ठीक है, माने in one cycle what happens, one thyristor and one diode it operates, ठीक है, तो their conduction angle is equal. T1 and D1 conduction angle is equal, whereas here the conduction angle of diode and thyristors, they are unequal, so it is also called asymmetrical. It out a point over. Okay. Oh. No one is asking conduction angle equal unequal. Understood everyone? Kali jota bujhaitla semiconductor. Are anyone respond na?
मैम राइट साइड रो कहीं के अनइक्वल अब
Coach. Okay. The symmetrical configuration, the waveforms are mostly, you can say they are equal in both the cases. Hala. Waveform equal achi, the expression for V0 and VRMS, it is also equal. But with the differences in the switching, which switch is operating. Okay. So this is the difference. And one more difference is that in symmetrical configuration, okay, in symmetrical configuration, the thyristor, it operates, you can say, in two modes. Okay, the thyristor, it operates in two modes. So the handling capacity of this thyristor, it has to be more as compared to this thyristor. So the waveform you'll able to know. So first, let us draw the waveform of this symmetrical configuration. So if this is your Vs, so that means suppose this is L is plus, N is minus. So how the flow of current will be, or you can say which two switches are forward biased? L is plus, N is minus. Which two are forward biased?
T1 and D1. T1 and D1.
T1 and D1. Okay, either forward bias. But again, we want a gate signal for the T1 to conduct. So suppose gate signal ame delu alpha hai. Okay. So it will be like L, T1, RL, D1, and then N. So up to pi. So it will be like this. Okay. Then after pi, this D1, after pi mane negative cycle. So this is plus. And this is minus. Okay. So after negative cycle, just a minute. So after pi, negative cycle asuchi. So the N will be plus, this one will be minus. Okay. But minus LAB, this T1, it will not, stop conducting because ek L achi, so L heba, because of this L, it needs a path for this discharge current to flow. Okay. And also, when there is a negative cycle, this T1, it requires some time to turn off commutation haba pai hela. So why? Because gote condition hela for this thyristor to turn off is that the anode current, it has to be less than your holding current. ठीक है, तो just at this negative cycle, this anode current is not less than the holding current, so you cannot say that T1 will stop conducting. ठीक है, but a discharge current पे हमको ଗୋଟେ path दरकार, because of this L there is a one discharging current. So for this path এটা দেখো, এটা যেটা n টা পজিটিভ হচ্ছে, this diode is forward bias now? No, D2 টা forward bias হচ্ছে, this one. Okay, so the discharging current will follow this path, D2, T1, R and L. ठीक है, D2, T1, R and L. So eta, so you can say this is my freewheeling mode. 8 in this mode there is a freewheeling action. So freewheeling action takes place from pi to pi plus alpha, because pi plus alpha रे मोर T2 operate होगा. ठीक है, so pi to pi plus alpha there is a freewheeling mode. Freewheeling mode is conducted by T1 and D2. So freewheeling mode रे the voltage across or V0 across this RL load will be 0. Because it is a short circuit path, हमें खाली ଗୋଟେ path दो जो current to flow କରିବା ପାଇଁ, है ना? So it is 0 up to pi plus alpha. पुनी pi plus alpha रे, that is negative cycle. T2 को हमें gate signal दे दो, suppose pi plus alpha. So T2 and D2 will operate. Okay? So again there will be some voltage like this. So this first mode is because of the thyristor T1 and D1. In the second mode, it is because of T1 and D2. In the third mode, we have T2 and D2. Then after 2 pi plus 2 pi, again there will be freewheeling action, but that freewheeling action will be done by T2 and D1. T2 and D1. So you can see here, from alpha to pi, which two switches are operating? T1 and D2. From pi to pi plus alpha, which two switches are operating? T1 and you all are understanding, Namu? I'm just, saying and you're saying. So pi to alpha, we have T1, D1, this opposite switches, T1, D1. Pi to pi plus alpha, we have T1 and D2. Okay? So you can see in both the mode, this thyristor is operating. That means alpha to pi plus alpha, T1 operate karuchi. Okay? But here, pi
to pi plus alpha freewheeling action is due to D2 or D1?
T1 and D2. T1 तो already say on है कि थिला ना 80 first mode रे alpha to pi.
हम को जो freewheeling action टा को diode जोगो
D2.
Okay.
Okay. So the conduction angle तो 80 में देखो pi conduct कुछ को pi to pi plus alpha. So what is the total angle? The conduction, I mean the thyristor is conducting from pi to pi plus alpha. तो कितने एंगल जे कंडक्ट करूचे? What is the difference between these two range? Pi. ठीक है. And the thyristor मोर तो 0 रही से forward bias हे गला. Then sorry, the diode D1 0 रही forward bias हे गला. Up to pi से conduct कला. तो 80 भी मोर conduction angle कितने हला? D1. D1 comes into this path रे आସୁଛି when it, T1 को जते fire करूଛ, but D1 forward biasing केतल होची, माने conducting माने कौन, D1 is ready to conduct 0 to alpha, 0 to pi, so the conduction is again pi. Or you can say like this, ये जो 0 to alpha, which diode will be, freewheeling action को पही हबो कहलो 0 to alpha, which two device?
D1, T2.
Ma'am, T2 D1.
T2 D1. T2 D1. So the sequence you can remember if I'm writing in another way. So we have suppose alpha ru start करूचे है ना, तो alpha ru है मोर कौन T1 D2, then freewheeling action है T1 D1, then negative cycle है कौन D2 T2 and D2, then freewheeling is because मु ठीक लेखुची no T1 and D1 freewheeling is because same leg रे जो दीटा device T1 and D2, then T2 D2, then T2 D1. Okay, so 0 to alpha it will be because of this T2 D1 Allah T2 D1. So now you can say D1 केते angle जे conduct कला pi. Yes.
Yes, ma'am.
Yes.
Yes, ma'am.
So here the conduction angle is pi. Okay, so it is same, so it is symmetrical. मुझे पेपर लिखिए कि स्कैन करके I'll send it to you about this one. Okay. Okay. It's 10:30. Wait.
Yes, ma'am.